The intake manifold gasket, or IMG, is a critical engine component that seals the intake manifold to the engine block. This seal ensures that the proper air-fuel mixture is delivered to the engine cylinders without leaks. In an exploded view, you can see the intake manifold separated from the cylinder head, with the IMG sandwiched between them. This gasket prevents air, fuel, or coolant from escaping the sealed system. The IMG commonly fails due to several factors. Heat from the engine causes thermal expansion and contraction, wearing down the gasket material over time. Vibration from the running engine stresses the gasket, while chemical exposure from ethanol-blended fuels and coolants can corrode the material. Eventually, material fatigue leads to cracks and leaks. When the IMG fails, it can result in vacuum leaks that disrupt engine performance, coolant loss causing overheating, and misfires leading to rough running. These issues significantly impact overall engine reliability. Vacuum leaks occur when air enters the intake system improperly, bypassing the throttle valve. This disrupts the carefully balanced air-fuel ratio in the engine. The result is a lean condition where there's too much air relative to fuel. This can cause the engine to run inefficiently and trigger various symptoms. Common symptoms include rough idling, noticeable hissing noises from under the hood, and the illumination of the check engine light. Modern vehicles often display diagnostic trouble code P0171, which indicates a lean condition in the fuel system. To diagnose vacuum leaks, technicians use smoke tests or ultrasonic leak detectors to pinpoint the exact location of the air intrusion. A failing intake manifold gasket can cause coolant to leak internally or externally, leading to overheating and white exhaust smoke. The intake manifold gasket seals coolant passages. When it fails, coolant can leak out of the system. Internal leaks occur when coolant seeps into the combustion chambers. During engine operation, this coolant burns off, producing visible white smoke from the exhaust. External leaks are easier to spot, as coolant may drip visibly from the engine area onto the ground below the vehicle. Overheating is a serious consequence of coolant loss. Without proper cooling, engine temperatures rise rapidly, risking warped cylinder heads or complete engine failure. If coolant levels drop but no external leaks are visible, the coolant is likely leaking internally into the cylinders and evaporating during combustion. Symptom 3. Misfires, hesitation and stalling. Vacuum leaks from a failing intake manifold gasket create uneven air-fuel mixtures in the engine cylinders. This disruption causes cylinders to misfire, resulting in engine hesitation during acceleration and rough running at idle. In severe cases, the engine may stall completely. Ignition timing becomes affected, leading to premature detonation as the spark occurs too early. Diagnostic tools like oscilloscopes confirm misfires by analyzing spark plug waveforms, revealing irregularities in the ignition pattern. These tools display the electrical signals, helping mechanics identify which cylinders are misfiring and why. Several vehicles are known for intake manifold gasket problems. The Ford F-150 5.4-liter Triton from 2004 to 2010 often experiences vacuum leaks and coolant loss, leading to misfires and even risk of engine fires in extreme cases. GM 3.1-liter V6 engines from the 1990s to 2000s are notorious for cracked plastic intake manifolds, causing coolant seepage into cylinders and resulting in blown head gaskets. Honda Accord 2.3-liter models from 1998 to 2002 frequently suffer from coolant leaks due to ethanol damage in the fuel, causing stalling and overheating. Knowing these common problem areas in specific vehicle models can aid in quicker diagnosis and repair. Regular inspections are key to catching intake manifold gasket issues early. Check the gasket visually every 50,000 miles for cracks or deterioration, and perform pressure tests to identify vacuum leaks before they cause major problems. Use specialized diagnostic tools to pinpoint leak locations accurately. Smoke machines introduce harmless smoke that reveals vacuum leaks, while ultrasonic leak detectors pick up high-frequency sounds from escaping air. Monitor coolant levels regularly and watch for signs of overheating or unusual exhaust smoke. Low coolant can indicate leaks, while white smoke suggests coolant entering cylinders and burning. For DIY diagnostics, consider using apps like Torque Pro that connect to your vehicle's OBD2 system. These apps can read fault codes and provide real-time data to help identify potential intake manifold issues early. Proper installation and maintenance can prevent intake manifold gasket failures. Follow factory torque specifications of 15 to 20 foot-pounds when installing or replacing the gasket to ensure proper sealing. Upgrade to high-quality aftermarket gaskets from brands like Felpro or Victor Reinz, which offer improved sealing properties and durability compared to OEM parts. Ensure your cooling system uses antifreeze-containing corrosion inhibitors to prevent gasket degradation from chemical exposure and electrolysis. Perform regular maintenance inspections every 50,000 miles to check for early signs of wear, which can significantly extend the gasket's service life and prevent costly failures. The rise of electric vehicles is reducing intake manifold gasket issues since EVs lack traditional intake manifolds. Hybrid electric vehicles, which combine traditional engines with electric components, are also influencing repair trends. Advanced diagnostics, including AI-powered OBD scanners, are improving leak detection by predicting gasket wear through data analytics. These tools can diagnose issues early, reducing the need for extensive repairs. Future materials like bio-based elastomers promise greater durability, reducing failures by up to 20%, according to industry projections. Virtual reality simulations can aid in training technicians for leak detection in a hybrid repair landscape, preparing for future automotive technologies. These immersive tools help apprentices learn diagnostic skills effectively. Overall, expect 30 to 40% fewer intake manifold gasket failures by 2030 as technology advances.